Hello, welcome to Mathematical Universe. In this universe, we'll be looking at conic section, and to be specific, we'll be dealing with parabolas. So, what is a parabola? Now, on my screen, you get a graph of parabola. You see a small sketch of parabolas here. But before we look at the sketch, let's talk about what parabola is. So, a parabola is just a locus of points equidistant from a given point called focus and from a given line called directrix. So just like the definition of a circle, which is a locus of points equidistant from the center of a fixed point, but in this case it is equidistant from a point called focus and a line called directrix. Now I will zoom into this one here so you take note of something here. So I'll be using a pen to indicate some distinctions here. Now, this point here is called the vertex. This point V is called the vertex. The point here is called the focus. You can see it here, labeled F open bracket A minus A comma 0. Sorry, A comma 0. Now, this A, let me zoom in again. This A here is the distance between the vertex and the focus. So the distance here is A. A distance here is the distance between the vertex and the focus. And if we move A unit to the other direction, we get the directrix. That is, if we move A unit to the other direction, we find the line of directrix. So this broken line here is called the line of directrix. Directrix is spelled this line of directrix. So what again do you need to know? Now, what is now the common equation you see? Now before we move to the common equation you see on parabolas, take note of this. Take note of this. I will delete this expression here. So I want you to watch this small clip here. You see this blue line is a parabola. The line at the back here is known as the directrix. Why this point here is called the focus. Point there is called the focus. So now let's look at the types of parabolic graph you can see in conic section. Now you take note of these equations here. The equation here, when y square equals to 4ax, we can either have y square equals to 4ax, and in that case it means the type of parabola is moving towards the right direction. You see the parabola is moving towards the right direction here. The curve is moving this way towards the right on the x-axis. If it is, and this is supposed to be a comma 0, sorry. Now if we are having it as y equals to minus 4ax, it means the a at the focus is negative, and by that time the parabola moves towards the left hand direction. Now this is supposed to be square here. Now if we have this type here where it is moving either vertically upward or vertically downward, then it means that the equation now becomes x squared equals to 4by, or x squared equals to minus 4by. So in that case, when it is positive, it moves upward. And if you notice in the Cartesian coordinate system, you see the upward direction is where we have the positive numbers, while the downward direction is where we have the negative numbers. So the formula makes sense. For when b is negative, then you have this expression. When b is positive, we have this expression for equation of a parabola. So we can have these four distinguished equations as equation of a parabola, but we mostly use this generally: y squared equals to 4ax. So just take note of this particular formula. Y squared equals to 4ax. Now, what about the canonical form? The canonical form of this, at where this is equals to x1, y1, that is, if this is at x1, y1, this case is a special case where the vertex is at the origin 0, 0. If you check all this graph here, the vertex here is always at the origin. Is at the origin here. If you check this other one also, you see the vertex is at the origin. And I told you the vertex V is this tip of this curve here. V is the tip of the curve. So it's always at 0, 0. So that is why you have it at this expression. But if it is not at the origin, then the equation becomes y minus y1 all square equals to 4ax minus x1. So it could be at any point on the Cartesian coordinate system. So that's why we have this as the canonical form or standard form of a parabolic equation. So let me write it. This is known as the standard or canonical form. Sorry, canonical form. Now looking at this type of graph, that is the one I told you about, which is given as y squared equals to 4ax. Now this type of graph, the curve is tilted towards the right hand side. Now here is the focus with distance a units to coordinate 0. Now you take note of something I want to say here. Going from the focus to the curve is 2a. That is, going from this focus to the curve here, the distance that is going to be covered is going to be called 2a. We are moving towards this direction as well. It's going to be called another 2a. Now these line segments that move from this focus to the curve here, and from this focus to the curve here, is called the latus rectum. So in other words, it means a latus rectum is a line segment that connects 2 points on the curve and pass through the focal points, because this is the focal point here. So latus rectum is this line here, and the latus rectum expression is given as 2a plus 2a, which you know is going to be 4a. So a latus rectum is spelled like this. This is a latus rectum, LACTUS RECTUM. So let's go into the first question. So look at the first question here. We are asked to graph the equation shown below. Graph the equation shown below.